Let's take a moment to review what SOHCAHTOA is. Remember, most people learn this for your basic trig stuff. We have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And what does that mean for this triangle? The sine of theta equals the opposite, BC, over the hypotenuse, AB. The cosine of theta equals the adjacent, AC, over the hypotenuse, AB. And the tangent of theta equals the opposite, BC, over the adjacent, AC. All right, draw an equilateral triangle. I drew it for you with side 2x. So we have side 2x, 2x. Label all sides. Draw the altitude. In this case, this is an auxiliary line. Now, my triangle isn't perfect. I just drew something down. Label all sides, lengths, angles using the triangles formed. Okay, so if it's an equilateral triangle, all the angles are equal. This is 60. This is my altitude. Now, what can I say about these two triangles and why? That's one of the things we're going to be doing, is always be able to justify why, prove it. What we did is we drew an altitude. Remember back in chapter 1, the altitude is a perpendicular to the opposite side. I know that 2x, this side is congruent to there, and I know the altitude is congruent to itself, and we have a right triangle, so therefore, by hypotenuse leg of a right triangle, these two triangles are congruent, and this angle is congruent to this one. In other words, they're both going to be 30 degrees. And then this bottom side will be half of the whole thing, so x and x. Let's compute this side. We could say 2x quantity squared equals x squared plus, I don't have a variable, let me call it h. For height, I'll call it h. So we get 4x squared minus x squared equals h squared. 3x squared equals h squared. Take the square root. Now we have a plus or minus, but the minus doesn't have any meaning because it's a length here. So we get the square root of 3 times x. Now note, there's a little sleight of hand that should say absolute value of x, but again, we're talking about a length, and so it's positive, and so we don't worry about that. So this is going to be the square root of 3 times x. Now let's find the sine of 30 degrees. Here's 30. Sine is opposite over hypotenuse, so it will be x over 2x, or 1/2. Cosine of 30 is adjacent, which would be root 3 times x over 2x, and we're left with square root of 3 over 2. And tangent would be opposite over adjacent, so the opposite is x, and the adjacent is root 3 over x. So we get 1 over root 3, which can rationalize to root 3 over 3. Similarly, let's do cosine, or 60 degrees. Sine would be root 3 x over 2x, or root 3 over 2, opposite over hypotenuse. Cosine is adjacent over hypotenuse, x over 2x, which is 1/2. And tangent opposite over adjacent, root 3 times x divided by x, or in other words, just root 3. Now take a moment, take out your unit circle chart, and fill in 30 degrees and 60 degrees for the sine, cosine, and tangents. All right, while we skipped chapter 6, we should be able to say what the equation of a circle is. A circle, and it's a unit circle, unit being 1. This is going to be x squared plus y squared equals 1. Now I'm going to call some point on the circle. Remember, when we graph, we need an x and a y. And xy will represent any point that's on this circle. I'm going to connect it to my origin. And I'm going to drop this down. I'll call this one theta. Now, since it's a unit circle, what's the length of the radius? It is 1. What's this dotted length? Well, that's just the distance from the x-axis up. That's our y value of the point. What's the horizontal length? That is x. So let's start to write sine and cosine using, find the cosine of theta and the sine of theta using the information we have there. Cosine of theta equals adjacent over hypotenuse, x over 1, or just x. The sine of theta equals the opposite over hypotenuse, y over 1, or just y. Now, take a moment and think about what we just did. This is pretty amazing. It's saying that when I have a point, any point on my unit circle, instead of saying xy, I can find that by knowing the angle, because it's going to be the cosine of theta times the sine of theta. Now, understanding this geometric relationship is going to be very important for us because we have to know the unit circle cold. If I ask you, what are the coordinates of some points here? Let's label some. First of all, this is a unit circle, so this will be 1, 0, and up here will be 0, 1, and then -1, 0, and 0, -1. What can you say about all cosine values in the first quadrant? Well, cosine is x. They are all positive. What can you say about the sine values in the first quadrant? Remember, this is first quadrant, second quadrant, third quadrant, fourth quadrant. The sine values are also positive. What about in the second quadrant? What can you say about cosine? Well, the x values over here, those are negative, and the y values are positive. Similarly, in the third quadrant, x is still negative, and this time y is below the x-axis, so that's negative. And then in the fourth quadrant, x is now positive, but y is still negative. And there's a little rhyme that people use, and they say, all students take calculus. And what it means is all trig functions are positive in the first quadrant. And in the second quadrant, sine is positive. In the third quadrant, tangent is positive, because when we draw a triangle, it'd be opposite over adjacent, and they're both negative values. In the fourth quadrant, cosine is positive. Now, this is going to allow us to say, what's the cosine of 100 degrees? All I need to look is say, where is 100 degrees? 100 degrees, this would be 90, so 100 would be over there. Cosine would be negative. When I'm saying what is it at this point, I'm just talking about what's the sine of it, S-I-G-N. So the cosine of 100 degrees is negative. What is the sine of 132 degrees? Again, this is done without a calculator. Look, where's 132 degrees? Well, that's going to be in the second quadrant, and sine will be positive. If I said, what is the cosine of 9 pi over 8? Well, I'd have to know, where's pi? Pi is half the circle here. So I have 9 over 8. 9 over 8 is a little more than 1, so it's going to be somewhere in the third quadrant. Cosine will be negative. If I said, what is the sine of 305.1 degrees? Now, you would just look, where's 305.1? We're going 90, 180, 270, 300 would be somewhere in this vicinity, 305.1. Sine is negative. Now, we have to know that, and we have to know it without thought. One of the things that I want to bring up is we have this circle, x squared plus y squared. And we can now use this. We know that's a unit circle. We know what x is. What's x? X is the cosine of theta. And what's y? The sine of theta. So we have our first identity, and typically we'll rewrite this. Now, in terms of notation, you would write it like this. And the standard way to write it, for whatever reason, is to say sine squared first. And we say sine squared plus cosine squared is always equal to 1 when we're talking about the same angle there. No matter what, it will always equal 1. And that's pretty amazing. All right, let's take a look at an in general triangle. If I call it this time, if it's not a unit circle, I'll call it R. And this isn't something that I typically tend to encourage memorization. It's not really needed as long as you understand the basics. But we could say the cosine of theta equals adjacent over the hypotenuse, and the sine of theta equals opposite over hypotenuse. And so there's our general circle. Let's take a look at the next part. We have if the terminal ray of an angle theta, now we talked about terminal ray in a previous section. If the terminal ray is in standard position and passes through this point, well, let's plot this point. +1, -2, doesn't have to be perfect. And there's our ray. What we're doing is we're starting at the positive x-axis and going around. Now, as long as we take into account the positive or negative lengths, it really doesn't matter. We can use this triangle. And I'll call this our horizontal length 1, and our vertical length is -2. We have our right triangle, and we can now say, what is the sine of theta? Well, I need to find this length, don't I? So this would be 1 squared plus, you could write it as -2 squared and then square root of that, and that would be square root of 5. We're just using the Pythagorean theorem. So the sine would be opposite -2 over the square root of 5. Notice we're in the fourth quadrant, so sine is negative there. And that rationalizes to -2 root 5 over 5. When we look at cosine of theta would be 1 over root 5, the adjacent over the hypotenuse, which just simplifies her to root 5 over 5. Let's take a look at the next. Next one will be very similar, except this time we're not given a specific point. We're given a value of sine, and we have to be very careful about this kind. I'm told that the sine, so we have some triangle, it's in the second quadrant. So I'm just going to draw some generic triangle in the second quadrant. I'm going to label the opposite is 5, and the hypotenuse is 13. Now technically, this is my angle theta, but again, as long as I take into account the positive or negative side, the hypotenuse is always positive. It's only the vertical or the horizontal lengths that can be negative. In other words, the x or the y values. Now we need to find x. So we have x squared plus 5 squared equals 13 squared. So x squared equals 169 minus 25, which is 144. Take the square root, x equals plus or minus 12. Now, which one do we want? The common mistake is to say that's positive 12, but it's not, because look what quadrant we're in. In this quadrant, x is negative, so it's -12. And then, now we can say the cosine of theta is adjacent -12 over 13. And that agrees because in the second quadrant we know the x value of this point will be negative. All right, solve this equation, cosine theta, where theta is in degrees. What we are going to do always when we're solving trig equations, we're going to use the unit circle. Now, on the unit circle, what is cosine? That's what we just did. Cosine is x. So what we're really doing is we're looking at x equals 0. What does that graph look like? It's a line. What kind of line? It's a vertical line. It is the y-axis here. Now, where does this line, this is a line, x equals 0, where does that line hit the unit circle? It hits it in 2 points. What are those points? Well, those are 90 degrees and 270 degrees. Now, is that the only answer? No, because we could either go 90, but couldn't we go all the way around? Yep. Could we go the other direction? Could we go around some more from there? Sure we could. So how do we show all of those? Well, every time we're going to be adding 360, so this will be 90 degrees, and we can say 360 degrees n. And we need to say here that n is an integer. And as long as it's an integer, that means we can go forward and we can go backwards. As well as 270 degrees plus 360 degrees n. So if you remind me in class, I'll tell you a story about this. If we're in radians, what's x? Well, we know the whole circle is 2 pi. Half the circle is pi. So this one will be pi over 2. And the other one will be down here, 3 pi over 2. And I'll write it like there. And we also have to say, now do we say plus 360n on this one? No, because we're in radians, so we have to say plus 2 pi n, where n is also an integer. All right, the last one. We have, what figure could you draw to find sine of 45 degrees and cosine 45 degrees? Recall what we did in problem number 2 in this lesson. We started with an equilateral triangle. This time, if we start with a square and we draw the diagonal, if I call this x and this x, what is the hypotenuse? Recall from geometry, it's x times the square root of 2. If you forgot that, you could quickly derive it. X squared plus x squared equals the hypotenuse squared. So that's 2x squared equals h squared. So h is the square root. We have plus or minus in this case. It's hypotenuse. It's a positive length. So it's just going to be square root of 2 times x. So what's sine? Well, actually, we need to get 45 in here. This is going to be 45 degrees, and this one up here will be 45. Sine is opposite over hypotenuse. X over x root 2, which is just 1 over root 2, and we'll rationalize that to root 2 over 2. Cosine would be the same thing. Since the cosine is adjacent over hypotenuse. And that is it for this stuff. Oh, no, it is not. Come back to your unit circle chart and fill in 45 degrees. Now, I didn't do tangent there, but could you do tangent? You can add that in. Tangent of 45 degrees would be x over x, which is 1. Now we're done.